Interpreting IR scans for experiment 5, the hydrogenation of vegetable oil. Vegetable oil that we are using is liquid canola oil. Vegetable oils in general are triesters of glycerol. So this is the glycerol piece on the left. You can see the ester groups are carbonyl OR, and there are 3 of them, hence we call it a triester. In the case of our canola oil, we don't really know how long these alkyl groups are, but typical of vegetable oils, they are long carbon groups with 1 or more carbon-to-carbon pi bonds per alkyl group, and so I've represented it by glycerol trioleate. After hydrogenation, the ester remains intact, however the alkenes are gone and we have simply alkyl groups. So once again, you must make assignments for the major characteristic absorption bands of the reagents and recovered products. And since this is now the 5th video, I won't read this. You can pause the video here if you want to review them before we continue. So step number 1 is to identify the groups that are present in our compound. In the case of the reagent, the triester of glycerol, you can see that there should be 3 ester groups, 1, 2, 3, which would appear identical. There'll be internal cis alkenes present, and then of course a batch of methylene and methyl groups present in our compound. Step number 2, we look at the generic scan for an aliphatic ester, and this is found on page 112. Now I have on that same page a generic scan of an aromatic ester, but vegetable oils typically don't contain aromatic groups, so it's reasonable to expect that these are in fact aliphatic, not aromatic esters. So what do we see for esters? Well, they show characteristic absorption bands for a carbonyl stretch and CO stretches. Now, esters might be mistaken for ketones were it not for the broad CO ester bands down here that distinguish them from ketones. So specifically, the carbonyl stretch at 1735 in the case of aliphatic esters. If you compare aromatic esters, you'll find the carbonyl stretch moves down to about 720. Conjugation typically lowers any given absorption band's wave number. The esters also have broad CO bands at 1300 and 1050. Pretty hard to miss this. So that takes care of the ester. Now bear in mind that the vegetable oil also contains internal cis alkenes, methyl and methylene groups. However, alkenes have already been described in interpreting IR scan videos part 1 and also in part 3 experiment 4. And likewise, the methyl and methylene groups are described in the interpreting IR scans videos part 1 and part 2 for experiment 3, so I won't do them again at this time. Part 3, we look at the assignments table for esters, and that's found on page 123. Notice here is the aliphatic ester, carbonyl stretch at 1735, and this is for 1 aromatic group on the left, 2 aromatic groups, 1 aromatic group on the right. None of these apply in our case. The CO stretches at 1300 and 1050. So that's all you have to assign on your table for an ester. This is step 4, where you actually make your assignments. Be sure to include, as I mentioned before, the cis alkene, the methyl and methylene groups, in addition to the ester groups. So I want to point out to you the prominence of the methylene rocking at 720, more than we've seen in the past, but we have a pretty good stretch of methylene groups here contributing to that. So this is step 4 a second time. This now is for interpretation of margarine from hydrogenation of the canola oil. So your product, the hydrogenated vegetable oil, should contain little or no unsaturation. in the IR scan of your recovered product margarine, look for evidence of residual unsaturation, the internal cis alkene. So for example, in this scan of margarine, I do see a trace of the double bond CH stretch at 30-20, characteristic of an internal alkene, and I see a trace of the double bond carbon to carbon stretch, again characteristic of an internal alkene at 1670. Also look for the, of course, methyl and methylene groups. So for the purpose of your lab report, you only need to submit 2 IR scans. One will be use the IR scan for canola oil that's right in your notes, and then use the IR scan from your recovered product. You don't need to do this particular one that's in the notes. Just do your own recovered product margarine scan. This particular scan would be for those students who for some reason fail to get a product. You can submit this one. So, yeah, enjoy.